science lab on physics Experimentalist. I have three theories. One, the theory of separation of charges, which comprises two concepts: A, separation of charges in conductor; B, flow of electrons in conductors. Two, the theory of Earth's electric field. Three, the theory of attraction or gravity. I will explain everything in details as I demonstrate my experiments, so it will be easier to visualize and conceptualize the scientific concept. One, the theory of separation of charges is further analysis for André Ampere's two parallel current-carrying wires. He showed when current flows in two parallel wires in the same direction, they attract each other. When current flows in the opposite direction, they repel each other. There was no logical explanation for Ampere's experiment. Of course, we know a straight current-carrying wire has flux lines in concentric rings around the wire. But what happened in atomic or molecular levels was unknown. I thought if electric field can polarize the water molecules in microwave oven, electric field in a wire can also polarize the copper's molecules in the wire. My scientific approach was right. The electric dipole moment is a measure of the separation of positive and negative electrical charges. An electric dipole moment in a molecule or substance is subject to a torque or angular acceleration when placed in an external electric field. The torque tends to align the dipole with the field. I also deduced whether the charge particles flow in 1 millimeter wire or 12,756 kilometer Earth, the separation of charges are the same. Electrons will be deflected by Lorentz forces and will undergo cyclotron motion. Two, the theory of Earth's electric field. I theorized the Earth's electric field is generated by thermoelectric effect. I do honor the existing dynamo effect. The thermoelectric effect is the direct conversion of temperature differences to electric voltage and vice versa. A thermoelectric device creates a voltage when there is a different temperature on its side. Conversely, when a voltage is applied to it, it creates a temperature differences. It has three effects: Seebeck, Peltier, and Thomson. All three effects are thermodynamically reversible. My theory is based on Thomson Effect or Lord Kelvin, which state heat is absorbed or produced when current flows in a material with a temperature gradient. Due to the unique characteristic of planet Earth and Thomson effect and temperature gradient between outer core and crust, the generated electric field or current in outer core, not only it is recycled through the magnetosphere, but also the current and the temperature gradient will sustain each other as long as there is a decay of radioactive elements and producing energy for the Earth's heat. 3. The theory of attraction or gravity is based on Albert Einstein's principle of equivalence, which state that inertial and gravitational masses are identical. I also used Earth's differential gravitational forces to accelerate different masses and calculate their angular accelerations and correlate them to the Earth's attraction or gravity. Science started with astronomy from Copernicus, Galileo, Kepler, and Newton. Before the telescope was invented, everything was based on observations. My theory of attraction is also based on my observations in 1960s. I was in high school, 7th grade. It was summertime. I had never seen a skyscraper. There was a construction site by us. I was watching the workers all day long. I became friends with most of them. I was watching a huge crane anchored, was hoisting the I-beams, 2, 3, 5 tons, lowering them so the workers could torque from both sides and bolt them to the vertical I-beams. It did not make sense to me. I thought if the I-beams were on the ground, it would be impossible for the workers to accelerate them. My second observation for the lighter objects, like steel bars or rebars, workers would tie them down with the strong ropes, lower them, so the workers could work and pour concrete to build the foundation. Next morning, I went to the construction site. One worker told me one of the rebars suspended by a rope rotated counterclockwise and stopped finally by a vertical rebar. He had no idea. Nobody exerted any force. How could a suspended steel bar rotate spontaneously? My third observation is also for the inertial and gravitational masses, which are indistinguishable in space. I noticed this in a small two-story building. One story was built already. One construction worker was on the top of the roof, and the other worker on the floor with the rubber gloves would throw bricks weighing about 1.5 kilograms upward. The worker on the roof would easily catch the bricks. It did not make sense to me. But if the worker on the roof would throw the bricks downward, it would be impossible to catch it. I also used concept of conservation of angular momentum to demonstrate many experiments and correlate them to the gravity, exerted torque or forces by Earth's lines of forces and Coriolis forces. I deduced the entire concept of gravity is imbalance of charges caused by Earth electric field and electromagnetic and electrostatic induction. It is impossible to attract anything without induction. If something works in atomic and subatomic levels, can also work in planetary levels. The strength of the magnetic field is proportional to the strength of the magnetic induction. Gravity is caused by Earth's direct current, which may exceed millions of volts. Due to the reversibility and interchangeability of laws of physics, both electrostatic and electromagnetic induction can attract everything regardless of their compositions. I have to explain about the Henry Cavendish torsion balance here because it's related to gravity. Henry Cavendish was the first experiment to measure the force of gravity between masses in the lab. He suspended two lead spheres, 158 kilograms each, also suspended two lead spheres, 730 grams each. Both spheres, 158 kilograms and 730 grams, had inertial masses only. Any attraction between two spheres would twist the suspended wire. And this is my logical analysis for Henry Cavendish experiment. Both 158 kilogram and 730 gram spheres are attracted to each other proportional to their masses. Both of them are lead, very poor conductors. Both of them are under the influence of Earth's gravity, but 730 gram, the smaller sphere is attracted or accelerated toward the 158 kilogram sphere and twisted wire. If I compare both the spheres with the Earth's gravity, they do not have any source to generate any magnetic field. They are diamagnetic. The determining factor is their electric charges. 158 kilogram sphere has more mass, consequently more electric charges, so attracts the 730 grams, a smaller sphere. We can even install a laser beam. Even the 158 kilogram will accelerate toward the 730 grams, which we cannot perceive it, but it might be micrometers. Now, I'm going to explain more about the Henry Cavendish experiment. Thank you. This is Henry Cavendish torsion balance. Well, of course, you can see this is Sir Isaac Newton's formula for universal gravitational force, and Henry Cavendish used his formula. Well, when you look at it, you can see this bigger sphere is 158 kilogram, and the smaller one, which is about 2 inches, is about 730 grams. But this is enlarged a little bit, you can tell, and Henry Cavendish was an amazing experimentalist, and it's very odd in the history of science. He repeated this experiment almost 29 times, and he came up with amazing, measurement. And then this small mass, which was 730 grams, was accelerated toward the 158 kilogram lead. Well, of course, there is a wire here, and then the acceleration caused this wire to twist, or they call it Torsion balance. And you can tell in a planetary level, always the Earth is accelerated toward the Sun. Sun is not accelerated toward the Earth. So was the Henry Cavendish experiment, and this small lead 730 was accelerated toward this. And this was amazing experiment, and they showed what Sir Isaac Newton said maybe 150 years ago, and he never ever conducted any experiment, but it came true. So Sir Isaac Newton's idea was absolutely right. But this is my analysis. When I compare these two formulas, this is for the Sir Isaac Newton's, is M1, M2 divided by R2, or the square. And this is also Charles Coulomb, which is called electrostatic formula. In my opinion, this works better in this case because both of them are attracted by Earth, but the determining factor here is electrostatic charges between a sphere, big sphere, and the smaller sphere. And you can tell this is the electrostatic formula Q1, Q2 divided by R2. And this is electrostatic formula. So just wanted to mention that, always the small asteroids or anything like that, or comet, they're accelerated toward the planet. Planet is never accelerated toward any comet or any asteroid. And I will explain more about this concept later. Thank you. This is my first theory, the theory of separation of charges. My theory comprises two concepts. One, further analysis for Ampere's famous two parallel current carrying wires, distribution or separation of charges in conductor in electric field, and B, flow of charges or electrons in conductor. In a minute, I'm going to demonstrate the way Mr. Ampere did. These are two parallel wires, and then it doesn't matter vertical or horizontal. Say I did it horizontal, you can also do vertical. So as long as the current flows in the same direction in this one and the other one, they're going to attract each other. But if I change the flow of electrons, one from the other side and the other one opposite direction, they will repel each other. I will demonstrate in a minute. So you can tell the flow of electrons in both wires are exactly the same. So they attract each other. I'm going to do one more time. So you can see they attract each other. But if I change the flow of electrons from positive to negative, they will repel each other. I'll show you in a minute. So now I change one from positive to negative and the other one from negative to positive. Now they should repel each other. See, they repel each other. I can also do this experiment with the vertical wires like this, and the result is going to be the same. Well, of course, there's no doubt that always there's a magnetic field when there's a charge, flow of electrons in the wires. And see, I did this like an experiment. This can be considered the wire. These are exact concentric lines around the wire. Well, of course, this is a little bit exaggerated. Each one, I would say, will be at least nanometer in between, and they just surrounded all around the wire, and depends on how strong the current is. And this is the way it shows. Always the concentric lines are around the wires, but there was no logical explanation why they attract each other or they repel each other. I have more experiments that I will demonstrate, and then I will explain exactly what happens. In fact, when we have flow of electrons or charges, regardless of which way is flowing, from negative to positive or positive to negative, charges are separated. But in order to prove that the charges are separated, I had to do so many experiments. I will show you step by step each one, and then I will prove that my point was right. The charges are separated. This is my second experiment. I used copper, aluminum, silver, and thin copper wires. I just wanted to demonstrate that it doesn't matter which way the current flows, from negative to positive or positive to negative, the charges are always separated. I used neodymium, which is the strongest magnet, in order to find out which side is repelled and which side is attracted. See, when I activate this side is going to be south all the way through the wire. It doesn't matter how long the wire is. I'll show you. So you can tell it's attracted when I face north toward the south. But it's the opposite. If I face the south toward the south, it's going to be repelled. I'll show you. See, it's repelled. I did more experiment. I'll show you in this next experiment. This is another experiment. I just wanted to demonstrate when the current flows, regardless of which way, negative to positive or positive to negative, all along the wire, we have south on one side and north on the other side. So I thought maybe if I bend the wire, they should repel each other. So my guess was right. If I bend the wire like this, see what happened? S is facing S and north is facing the opposite. And it doesn't matter. If I bend it the other way, it's going to be the same. So in this way, north is going to facing north, so they repel each other. So this was my experiment. I bended this wire, and then I'll show you. See? They repel each other. This is another one. This is another experiment. Regardless of the shape and the size, when the current flows in exactly like a wire, they're going to repel each other. These are 2 pieces of aluminum, and these are 4 inches copper. So I'm going to connect, you can tell, it's repelling each other. See? To apply more current so we can tell the repulsion is much better this time. See how much they repel each other? This is another experiment. I had the wires, only one layer one of them is clockwise and the other one is counterclockwise. So you can see clockwise is facing the counterclockwise, and it's exactly like one wire, but the difference is this has more winding. If I connect it to 12 volt DC, you can tell it's going to be a traction. But if I change the orientation, even though I'm not changing the flow of current or flow of electrons, it's going to be repulsion. So now you can tell clockwise is facing the clockwise. It's exactly like the wire, but like I said, this has more winding. Let me see if I can adjust this. Okay. You can tell they repel each other. Well, I have to explain about the dipoles. So you can tell I did not change the flow of current from negative to positive. What I did, I changed the orientation. This is called dipole. I have to explain. Electrons have magnetic dipole moments. Since the separation of charges are 360 degrees all around the wire, and they extended all along the wire. When we loop the straight wire clockwise or counterclockwise, the electron's magnetic dipole moments or orientation is reversed with reference to the flow of electrons in the wire. Electric dipole moment has to do with the orientation of the dipole, position of charges, and does not indicate the direction of the field originating in these charges. As soon as I rotate the south pole V to the clockwise, both loops are assumed the same polarity. I did not reverse the flow of current. Electric dipole moment is a measure of the separation of positive and negative charges. This is another experiment. I just wanted to demonstrate that how the separation of charges are affecting the total magnetism. What I did, this is a special experiment. The bottom winding is clockwise and the top one is counterclockwise. Each one individually is so powerful, I'll show you. If I connect it to 12 volt DC, they pull that iron wire strongly. But as soon as I connect both together, the total magnetism is zero. The reason why the top is exactly like the other experiment, the arm is facing like south or north, is facing exactly south like this. So in other words, they're exactly the same polarities and the total magnetism does not add up. I'll show you a minute. You can tell how strongly it pulled the iron wiring. But now I am going to connect top and bottom together and make it one. See, this is top and bottom. I connect them together, so the total magnetism will be zero. The reason why? They do not add up, and this all because of separation of charges. And it doesn't matter which way the current is flowing, from negative to positive or positive to negative. You can tell there is no magnetism whatsoever. Of course, I did more experiments. See, like this is the one I showed before. When we bend the wire like this zigzag or go clockwise to counterclockwise, you can tell S is always facing S. N is facing N. It doesn't matter which way I do the zigzag. So this is another example. I did something like this, zigzag. And then this is exactly like this ordinary solenoid. This is so powerful. The reason why the magnetism always adds up, because everything, the orientation is the same. But this one is different. You can tell wire is not continued from here. So it's exactly like S is facing S or N is facing N, depending upon which way the current flows. When I connect this to 12 volt DC, it's exactly like my magnet, these two coils. There won't be any magnetism whatsoever. This is another one. Almost, 3 layers are clockwise and 3 layers counterclockwise. So the way I did, one layer was clockwise and immediately I changed the wire to counterclockwise and back and forth. So technically 3 layers are clockwise, 3 layers counterclockwise. You see, ordinary, this would have been real powerful solenoid. So is this one. But as soon as I connect these two, they cancel each other.